We have now installed PrimerMiner, and next we want to download sequence data for the organisms we are interested in. We need 3 files for this. One is a table which contains all the taxa we are interested in, so this is this one here. Then we need to generate a configuration file. This is done by running batch config, and then we can use both files to start the batch download process. So let's go over these 3 steps one by one. We start by taking a closer look at the taxonomic table. I open this one here in the standard text editor, and you have basically 2 columns. The first one is for orders and the second one is for families. You can also use this program to download data for subfamilies and other taxonomic levels. However, I would not recommend that because, for example, on a genus level or species level, the program really struggles because sometimes the genus name is not unique, so it will find several hits on the databases and then crash. So I recommend using this program for order or family level. So in this table here, we have order and family. So the first column we have here, for example, Coleoptera, and then we have a comma to separate this from the second column. We leave this one here empty because in this case we want to specify for Coleoptera, the order, which are beetles, we want to download only aquatic Coleoptera. There are of course some more aquatic families for Coleoptera, but in this case I'm just downloading a small subset for demonstration purposes. So we basically specify here the folder in which all the data should be loaded, but this is not downloading all Coleoptera, it downloads just everything which is here in the second family column. You also see here that we download 2 more groups. These are Perlide and Nemoride, and those are again families, but you could also write here just orders. In this case, for Perlide, we don't specify anything else here, so what PrimerMiner will do, it will search for everything matching Perlide and takes this name Perlide as a group it has to download data for. So it opens a folder which is called Perlide and downloads all the sequence data it finds for Perlide. So we haven't specified any other taxonomic information, any subset we want to download data for. So if you want to download data, you can just change this stuff here. So for example, if I just type here Plecoptera, it will now also download complete sequence information for the order Plecoptera. We can save this file and close it again. To create a configuration file, let's go back into R. And in here, we're going to change the working directory to sample data. So this is my folder here. This one, sample data. And in here we already have our taxonomic table, which we just created. And we added here the Plecopteras. Now it's time to create the configuration file. And we can do this by running the command batch config. We run this. And this will create in the current working directory this configuration file. If we take a closer look at this file, you find quite a lot of options in here. And if you are interested in downloading data for the cytochrome oxidase subunit 1, which is the standard barcode for animals, you can basically leave everything in here as it is. I just want to point out to you that on default settings, we apply some clipping to NCBI and bold data, which is very important because sometimes sequences still have primer fragments in them, so the Sanger sequences were not trimmed how they should have been trimmed, so therefore we apply some extra trimming to all the sequences. In some cases you might want to turn this off, so you would just replace this here by 0. But in our case, we're just going to leave this as it is. Let's maybe go over some of the options. The marker here is cytochrome oxidase 1, CO1, and you can just change this query if you, for example, are interested in the 16S marker or some plant markers. You can specify this here. Should you, for example, be interested in a plant marker which is not on the mitochondria, you want to turn download mitochondria off, so you replace the T with the F for false. So this way, no mitochondrial data will be downloaded. On default, however, this is turned on, so what will happen is that mitochondria, complete mitochondrial and partial mitochondrial genomes are downloaded from NCBI, and the marker of interest is automatically extracted if it is present. So in this case, the complete CO1 gene is extracted from mitochondrial genomes. Down here, you will find some clustering settings. So at the moment, we are working on a Mac operating system, and we use vSearch, which comes with the PrimerMiner package. We do clustering at 3% similarity, and then we build consensus sequences from the UTUs, which we generate, so the operational taxonomic units. So you can roughly say that each UTU represents one morphological species. Of course, sometimes you have cryptic species. So personally, I think 3% is a good threshold to capture most things on species level. The consensus sequence is built based on a majority rule, so at each position, the most common base is used in the consensus sequence. So those were the most important points of the settings here. There are some more information on the wiki, on the GitHub page, but for now I will just close this one again and we don't change anything, and we're just going to run the script. The third step is starting the script, and this is actually quite easy. We go on batch download, and in here we have the taxa table and the configuration file, which we have in this folder here. And we're just going to press Command Enter to run this line. And you see immediately a folder is created. Let's get this one out of the way so we can see what happens. We see that data is downloaded for Bolt and also NCBI for the different Coleoptera family we are requesting. And typically NCBI is a little bit slower, so once it has downloaded all the sequence information, sequences are dereplicated, mitochondrial genomes, the marker for mitochondrial genomes is extracted, and the sequences are clustered. If we take a look at Coleoptera here, you see that we have here, for once, the downloaded raw data, and then we generate different files which are used for clustering. And Coleoptera all contains all sequence files. Those are then dereplicated again and clustered. And the consensus sequence is saved in Coleoptera all cons cluster majority. We see also here that 1,300 input sequences were dereplicated and resulted in 186 OTUs. And those are now contained in this file. So this is the main file we are working with and which we use to build our primers on. While the script is running, I might point out that sometimes we don't find the marker in the mitochondrial genomes. This can have two reasons. The mitochondrial genome might be partial, so not complete, and does not contain the CO1 gene, or it could be that it has a weird annotation and then it doesn't find the CO1 marker, which isn't defined in our search parameters. So if you want, you can import this file into Genius and take a closer look and figure out if the CO1 marker is present in here or not. Should you decide to add some sequences, you can do this by going into the configuration file. And if you want to, let's say, add some custom sequences, own sequences you have, or you find some more sequences in the mitochondria you want to add to your dataset, you can set download here to false, and then go ahead and, for example, for Coleoptera, add one file here, which you call with an ending _mito.faster, so it will be included into the clustering process. And then you just save this file and run it again. This time, data will not be downloaded, but all the data you have in these folders here will be merged. You also if you do this, have to delete this little file here, which is saying done.txt, because once the clustering is finished, the program will not do the downloading and clustering again. Only if this file here is removed, it will start the clustering process again. This has the reason that sometimes the program can crash because the server isn't responding and you get a timeout. And should this happen, you can just restart the script again by running this command, and it will only download folders which were not completed. So for example, the Coleoptera here, all the data is already downloaded, so there is no need to re-download everything again. If you turn this one here off, it will download the data and overwrite the old files again. Let's close this one, and we don't want to save any changes, and let's wait till this downloading and clustering here has finished. Okay, now PrimerMiner is telling us that it's done downloading and clustering all the files, and it has also created some summary statistics for us to look at if you are interested in this. So depending on the size of the dataset you are downloading, sometimes you almost download 1 million of sequences. This program can run for a few hours, but it still works even if you download sequences very diverse and abundant taxa, like for example dipteras or something like this. The next step will be to now take this data and align the OTU consensus sequences. So if we take a look in this file here, you see we get quite a lot of sequences, and now we need to align all of those so we can evaluate our primers. I'm going to show you how this is done with Genius in the next tutorial.